Hey Electronics and Coding, welcome to your screencast intro to the shift register. Sorry, I should have written this on the top already. Okay, so the shift register is a integrated circuit that looks a lot like the H-bridge. You've seen it in your kit before, but it has a very different functionality and wiring, and we're going to talk in class. We're going to find it in your kits and we're going to label all the different pins, but this screencast is basically an introduction to the functionality of the shift register and why we might want to use one. So you might have noticed that your Arduino has 13 input output pins. I guess I should say digital input output pins. And some of you might already be thinking about projects that you want to do outside of class, and you might be wondering, well, what happens if I want to use more than 13 components? One of the most common uses of the Arduino is to hook up a ton of LEDs. So what if you wanted 50 LEDs? You couldn't do that with only 13 pins and control them individually. So if you want to start blinking 50 LEDs or controlling other digital outputs, here is where a shift register can come in real handy, because it controls, you can expand your I/O, your input-output capability without having to pay a whole lot to get a more expensive microcontroller, because you could buy an Arduino Mega for like, I don't know, $50, maybe a little bit less than that. Or you can use a shift register to increase your I/O pins. Okay, so that's what we're going to be using the shift register for, to expand the capacity of the Arduino without buying a more expensive microcontroller. Okay, so the shift register can control 8 different outputs, but it does that using really only 3 input pins. So the diagram that we are working with here, this simulates the output. So here we're kind of modeling LEDs, and if they are white, that means that they are low and unlit, and if they are red, that means that they are lit. And the shift register has can control these 8 output pins with only 3 input pins: the clock, the data, and the latch. So I guess it's just most helpful to go through and explain the sequence of how you would use the shift register. Okay, so we start off with a shift register that is totally empty of values. Or I guess it's not empty, but it's holding all zeros. So the outputs that you see on the LED are all off. And we start the cycle with the latch going from high up here to low here. And our initial value on our data pin is low. Our initial value on the clock is also low. Okay, so shifting over this direction, following the green arrow, this next, I guess if this is time equals 0, this is our start. T equals 0 seconds. Now, maybe I won't say seconds, but just T equals 0, because it's going to happen much faster than a second. And now this is T equals 1. It's just a fraction of maybe less than a millisecond later. Our latch is still low. Our data pin is now, we write to it high. So before our data was low, now we write our data high. And while we're writing our data, so our data's high this whole time, we cycle the clock from low to high. And what this does is when the clock goes from low to high, why is my my eraser's so giant? Okay, so when the clock cycles from low to high, the value, value on the data pin will be shifted on to position 1 within the shift register. So, as you can see here, because our data pin is high, and high is, in computer talk, equal to 1, when the clock cycled from low to high, now position 1 in our shift register is holding the value of 1. Okay, moving on down to the next image down here. Now, our latch is still low. Our data pin has been shifted from high to now low, and our clock cycled high and then it cycled back to low again here. And now, once again, our clock cycles from low to high. So, did I say this before? But this is called, the clock is driven on the rising edge. So this transition from low to high, whatever the value is on the data pin is going to be now shifted on to the shift register. And any subsequent, or any value that's already in the shift register will be shifted down a position. So in position 1 originally, maybe we should call this for ease position A, and this is position B, and C, and so on and so forth, so it's a little bit easier. Now, in position A is a 0 because currently the reading on the data is 0. So as our clock shifted from low to high, we put a 0 in our A position, and that 1, which used to be in A, is now shifted down to position B. So the clock not only drives the transformation of whatever reading is on the data pin, but it also shifts every subsequent reading down 1 position on the shift register. Okay, now we move over here. Now, then the clock has cycled from low to high. We've recorded whatever's on the data, and it cycles back low again. We go over here. Now the data pin, we shift it to high. We drive the clock from low to high, and so now we store this new value in position 1 in A. We shifted that 0, which was just in position 1, now to position B, and the original 1 from here, maybe we should give it a color. Oh yes, this is our green one. This is how I should have done it. So our green one is here, and our green one is here. Our blue 0 is here. Now our blue 0 is here, our green one is here, and now we have a new red one here. And the same thing is going to happen. I could talk you through this whole thing. So basically, anytime the clock cycles from low to high, whatever's on the data pin is going to be shifted into the first position, which is our A position here on the shift register, and everything else is going to be pushed down 1 position. So we do this many times. The data is now high. We cycle the clock. Now we get a 1 here. Da, 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 da. The data is now low. We cycle the clock. We get a 0 here. And you can see, this is our original green 1. The first 1 that we shifted onto the shift register. And it is traveling down the length of the shift register until it's all the way, if this is position A, B, C, D, E, F, G. This is position H on the shift register. Okay, so this is our last cycle of the clock. We cycle the clock from low to high. Our data pin is low, so we record a 0 in the A position, and the latch is low. The latch, you might have noticed, has been low this entire time that we have done this activity except from the very beginning when we cycled from high to low to start off. So this is important. In this last bit, our data pin is low, our clock pin is low, but our latch cycles from low to high. Now, this is important because every time the latch cycles from low to high, we move information from the shift register to this kind of arrow is depicting the storage register. So these values, 0 and 1, 0 and 1, 0 and 1, were in our shift register until we cycled the latch from low to high, and now they end up in the storage register. And what that means is when things are in the storage register, we actually see the physical outputs. Oops. Outputs are visible. We write the values of low or high to the pins that are connected to these LEDs. So in our example above, you see, even though we had a 1 in the shift register, and then it was here, and then it was here, and then it was here, we never saw it in actually as an output on the LED. We never saw a high value on this LED because all this information was still in the shift register. We have to cycle the latch from low to high in order to transfer this information into the storage register, and then we see the LEDs illuminated. It can be kind of helpful to see this happening in a simulation. So here you see every time the clock cycles from, oops, this is actually happening pretty quickly. I think if we slowed it down, can we slow it down? I guess not. Okay, every time the clock cycles from low to high, whatever value is on the data pin is shifted onto the shift register, and then those values travel down the shift register. So if we track these ones, they're moving down here, 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 here. And then when we cycle the latch pin from low to high, the values that are in the shift register are transferred to the storage register. And then we see the outputs of the storage register in the LEDs in this image. So you can see here, we're writing a series of zeros and ones, and then we're inverting that. So if this was a 1, this would be a 0 next round, and our LEDs can cycle from on, off, on, off, on, off, on, off, to off, on, off, on, off, on, off, on. So hopefully this makes a little bit of sense, and we're going to be doing a lot more with the shift register in class to really drive all this stuff home. So if you're just starting to get it, that's the perfect place to be. Totally get it. Amazing. You'll be a leader in class tomorrow. I'm looking at you, Henry. Okay, that is all.